Good morning, third period. I am so sorry I'm not here to teach this to y'all in person, but I think this video will do the trick. Make sure that your volume is turned up where you can hear it and that you have headphones in so that you don't disrupt others around you. As you came in today, you should have grabbed one of the notes pages, so it should look like mine. And today's lesson, the main focus is prime factorization. To start out, we're going to go over just what a regular factor would be. So this example is just finding the factors of a number. It says Anna wants to build a rectangular garden with an area of 24 square feet. What are the possible whole number lengths and widths of the garden? So if you think about it, if we have a rectangle, okay, and we have an area of 24 square feet. What that tells you is when you find the area of a rectangle, which is length times width, or sometimes we refer to that as base times height, okay, that you're trying to find two numbers that when you multiply them together, you get 24. And those would be the factors of a number. So they already have this problem done for you. So we have 24 as the length and 1 as the width if you multiplied those together. So 24 times 1 is 24. 12 times 2 is 24. 8 times 3 is 24. And 6 times 4 is 24. And so these would be all the possible factors of 24. And so if I asked you to list those, normally we do them in order from least to greatest. So I'm going to list them 1, 2, 3, 4, and then we're going to go up to here 6, 8, 12, and 24. And so here are some examples where we're just going to find the factors of these numbers. So if you look at 21, I know for sure that 1 times 21 gives me 21. And notice I left some space for the other factors to come back in. At this point, I'm not really sure how many there are, so I just left enough space so that we have room. And then you can ask yourself, okay, do we think 2 goes into this? No, because it's not even. And so we'll try 3. Well, I know that 3 times 7 is 21. And so then I'm going to ask myself, okay, what about 4? No. 5? No. 6? No. And then you get up to 7, which we already have, and we know there's nothing after that. And so this would be your complete list of factors for 21. Okay? Then over here I look at 37. Again, I know 1 and 37 are factors. I try 2, and 2 won't work because 37 is not even. 3 won't work, and 4 won't work, and 5 or 6. Okay, and we keep going and we realize that's it. Those are the only factors of that number. What that tells you about 37 is that 37 is a prime number because it can only be divided by 1 and itself. 21 would be considered a composite number because not only can it be divided by 1 and itself, but it also had another set of factors. 24 that we talked about earlier is also composite. It has a lot of factors. Okay, so I'm going to give you a second. I want you to try to find the factors of 42 and 30. If you'll pause this video until you've completed 3 and 4. Okay, now that you've completed 3 and 4, you should have ended up with 1 and 42. 2 times 21. 3 also goes in there, and you should have ended up with 14. 4 does not go in there. And 5 doesn't go in there because 5 would have to end with a 5 or 0. So we go up to 6. I know that 6 times 7 is 42, and then that completes my list. For 30, you should have ended up with 1 and 30. I know it's even, so 2 and 15, 3 and 10, and then we end up right in the middle with 5 times 6. Both of these are also composite numbers because they have those factors. So those are just basic factors of numbers. The big part of this lesson today is finding the prime factors. So we're going to go ahead and move on to finding the prime factors of these numbers. And to find the prime factors, the best way that I can teach you is to draw a factor tree. And you might have seen these in 5th grade. Some of you might not. But we're going to try to find the prime factorization. What that means is by the end of it, I am only allowed to have prime numbers in my list. If you look up here at our regular factors, notice we had numbers like 6 and 21. I know those numbers can be divided by more than just one in itself. And so these would not be a list of prime factors. These are a list of just regular factors. When we get our list down here, we can only have prime numbers. So to start out, I'm going to try to find the prime factorization of 12. To find the prime factorization, I'm going to pick 2 factors that I know for sure. They don't have to be prime right now, but I'm just going to think of 2 numbers that when I multiply them together, I would get 12. So I know that when I multiply 2 times 6, I get 12. If either of the numbers that you wrote are prime, I want you to circle it. Prime means that it can only be divided by 1 and itself. And so 2 is a prime number. 6 is not prime because 6 can be divided by 1 and 6 and also 2 and 3. And so I'm not allowed to circle it just yet because it's not a prime number. So what I'm going to do is I'm going to break this down even further. And I think what factors would multiply to make 6? Well, I know that 2 times 3 is 6. And then I'm going to circle those if they're prime. Well, I know 2 is prime because it can only be divided by 1 in itself. And I know that 3 is also prime. It can only be divided by 1 in itself. And so the prime factorization is actually the numbers that you circled. And when I write my prime factorization, instead of it being in a list like it was up here, it's going to be a multiplication problem. So it looks like this. 2 times 2 times 3. Because 2 times 2 is 4, and 4 times 3 gives me the 12. You should always be able to equal back to your top number. This is one way to write it. The actual simplified version is you're going to combine the 2's and write it as an exponent. So if you remember what we talked about earlier this week with exponents, if I have 2 times itself or 2 times 2, I can write that as 2 squared, and then we're going to bring over the times 3. That would be your final answer. Okay, so this would be the prime factorization of 12. Let's take a second and think of some prime numbers. The basic ones that you probably are going to see today, we know 2 and 3. Would you say that 4 is prime? Can 4 be divided by something other than 1 in itself? It can. It can be divided by 2, and so it is not prime. So we're going to move up to 5. Again, 6 can be divided by 2 and 3, so 6 doesn't work. 7 is prime. 8 can be divided by 2 and 4, and so then we go up to 9. 9 is not prime either because it can be divided by 3. 10 is not prime. It can be divided by 2 and 5. And then we move up to 11. 11 is prime. 12 is not prime. 13 is. 14 is not prime. 15 is not prime. 16 is not prime. We move up to 17. 18 is not prime. And 19 is. And that's normally enough prime numbers for what we're doing today. Okay, So let's try 36. So I want you to think of two factors that when you multiply them together equal 36. And you can use any of the factors. In this case, I'm going to use 4 times 9. You could also use 6 times 6. We will all end up at the same answer if you chose 6 times 6. That is no big deal. We will all end up in the same spot. So these two factors do not matter as long as they multiply to become our top number. Are 4 and 9 prime? Well, if you look at our list, they're both composite numbers. They can be broken down further than this. And so 4 becomes 2 times 2. We know that 2 is prime, and so I'm going to circle both of those. And then 9 can be broken down to 3 times 3. 3 is also prime, and so we get to write this as 2 times 2 times 3 times 3. Again, as exponents, this becomes 2 squared times 3 squared. And you can always check yourself. 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. And so this would be our final answer. Now I want you to try finding the prime factorization of 120 on your own. Go ahead and pause this video until you're done. Okay, so you've completed the prime factorization of 120. You might have started with different factors than I do, and that's okay. I'm going to start with 10 times 12. Neither one of these are prime numbers, so I'm going to keep going. 10 becomes 2 times 5, which both of those are in our prime list, so I'm going to circle them. And 12 is 3 times 4. 3 is prime, so I'm going to circle it. 4 is composite, so I'm going to keep going. I'm going to break it down further to 2 times 2 and circle those. So when I write the prime factorization here, I'm going to combine all the 2's, then I'm going to move to the 3's, and then I'm going to move to the 5's. It's important that you put those in order from least to greatest. So we have 2 times 2 times 2 times 3 times 5. And so if I were to write that using exponents, I have 3 2's here. So that's 2 cubed times 3 times 5. And remember, you can always check yourself and multiply that out and make sure that you get 120. I've got a challenge problem for you. Go ahead and try 300 and pause this video and come back when you're done. Okay, now that you've completed 300, we're going to start with two factors. Again, you might have picked different ones than me, but you should all end up at the same place as me at the end. So I'm going to do 30 times 10. Neither of those are prime, so I'm going to keep breaking it down. 30, I'm going to choose 5 times 6, circle 5. 6, I'm going to choose 2 times 3. And we get to circle both of those. I have to come back up to the 10 and branch off of it. So 10 becomes 2 times 5. Both of those are prime. And so I'm going to write my prime factorization, again, in order from least to greatest. So I'm going to put my 2's together. 2 times 2 times 3 times 5 times 5. And again, using exponents, we get 2 squared times 3 times 5 squared. And that's your prime factorization of 300. Feel free to rewind this video, to pause it, to rewatch parts of it if you need extra help before you start your homework. If you think you're ready to go pick up a homework from Mrs. Fox, and I will see you guys tomorrow.